Hi, welcome back to Mini Rust in Rust. This is episode 34. We're writing a little programming language that looks a bit like Rust. In Rust, it's going to be interpreted. So it'll be, I feel like, ideally, it would be like a Python-like language, but with Rust syntax and nice type checking and stuff like that. At the moment, we're just getting basic stuff working. The example that is kind of pushing us is this example of a little kind of snippet of code which calculates the factorial of 3 by doing a while loop, modifying some stuff, and then giving us back the answer. And last time we got these mutation statements to work, the times equal and the plus equal, and we're kind of halfway in, because we thought we were going to be getting a while loop to work last time, but it turned out we hadn't done the mutation statements, so we did those instead. Now I'm hoping we're going to get some or all of the while statement to actually work. So we've got a failing test, which we've ignored, which says a while loop whose condition is false does not evaluate the block. We've written a little bit of test code which says we start off with an x that's set to 0, and then we say while, and then something that's not true, then add 1 to x, and then give us x back. And the point is, x shouldn't get modified because 20 is not less than or equal to 1. So the answer should still be 1. Sorry, should still be 0. Shouldn't be 1. So let's unignore that test and run it and see what happens. It may already pass. Well, I think it'll probably just crash because we don't know what to do with a while loop. Just let it compile. Yeah, so it's failing at line 218 of evaluator.rs because we half wrote some code to do this and we didn't actually finish it because we realized it wasn't what we were doing. So this is the code. Let's look at where this is called. This is the code that when we've been given a while, we've parsed it all out and we've figured out this is a while loop. And now we're in the evaluation code. This is the evaluator code. This eval tree is like the top level function of like actually evaluate some stuff, where evaluating means basically calculate the answer. So we've done the selecting and done the parsing, we've done the type checking. Now we've got a type syntax tree containing these syntax nodes, and we need to actually find out the value of those things, or like run that code. Evaluating means running the code. So we're going to run this while loop, and we're going to capture that all inside a function called eval while. And I guess the first thing we can do is we can probably have this test pass by just saying, just hard coding the fact that the while loop returns a 0, let's say, because that's just going to get thrown away, I think. Actually, let's make it return something weird, and then we'll know if that value's kind of cropping up somewhere it shouldn't. Run the test again. And okay, so the test is kind of passing, except we've still got this weirdness, which is that the return value of a block of code like that is still the value of each of the statements inside it. So this is the let, this is the while, and then this is the like print out x at the end or return x at the end part. So it is actually working. X is 0 at the end, but we have to like account for the fact that we've done this weirdness. So I guess we've got to change this back to 0. And then we've got to change our test to expect 2 zeros. Where's my test for while loops? Here. So actually, right now, this is going to return 0 for that let, 0 for the while, and then 0, the actual 0 we're interested in. So now our test is going to pass. Now, it's very soon we've got to come back and fix this weirdness. This is no good. But not right now. I think that'll be what we do once we've got this snippet of code working, hopefully. Okay, so that was quite easy because the while loop does nothing, but now all while loops do nothing. So we need a test which checks the other side. Excuse me. So let's do that. So a while loop whose condition is true does evaluate the block, and let's just have it be true once. So now we're going to say while x is less than or equal to 0. So now we're going to do the loop exactly once, and the answer that comes out at the end is going to be 1. And I guess we should also say, later we'll say that it evaluates multiple times, but let's try this first. When we run this test, it fails because the last value still comes out as a 0. It should come out as a 1. And the reason is that we haven't actually executed the body of the while loop. So let's find our code that's supposed to do that. Here. And instead of just returning 0, we should do something. So I think we just kind of need a while loop to evaluate this while loop, I think. So we want to say something like while, let's ignore these. While the condition expression, we've got to evaluate that condition expression. So let's just say we're going to call one of our own functions, which I think is going to be eval tree. So when we evaluate condition expression, and we want some kind of is true here on this, so we're going to get back a value, and I suppose that value is going to need to be of type bool, and we don't actually have Boolean values yet, so I feel like we're going down another digression before we can actually make this work. But it's going to be something like, while this thing, which should definitely be a bool, maybe while is getting ahead of ourselves. Let's just get hold of the value. So let cond equal evaluate the tree, and that could error, so we need a question mark on that. So now, this should be a mutable reference to self, because anytime you evaluate stuff, you might modify the environment, which is part of our evaluation thing. The environment is just where all the variables are stored. So now we've got back cond, which is a value, and that value should definitely be a Boolean value, and we don't have those yet, but let's just imagine for a second. So we're going to say let that answer should be a Boolean. So we're going to imagine that a Boolean thing exists and that we've got it out, and if not, then something went wrong. So we're going to return some kind of error, which will be, now we've got some errors down here, things like invalid number. I guess this should be invalid type for Boolean or something. Like, this should never happen because our type checking code should stop us getting here. Although we haven't written our type checking code yet, so it will for now. So this should be something like, let's just say wrong type for Boolean condition. We'll just say that here. Wrong type for Boolean condition. And I guess we could say the type, couldn't we? So let's just have something in here which is supposed to tell us what the type was. And I guess we should also say the value, right? So we should have a value here. Like describe the value we got and describe its type. So here we're going to say wrong type. Type. Boolean condition. I guess we'll just say value is something like that. So now when we get this error, we're just going to say the wrong type. Let's say this was a string. We're going to say wrong type string for Boolean condition. Brackets value is hello. Something like that. So let's use that here. Actually, let's look at another place we return an error and copy it because it gets quite confusing. Some of this stuff we're going to share. We need to call .into on that. I mustn't forget. Converts it into a Miet error. So type is going to be, let's just say to do type for now, because again, we're not going to actually do this yet. Value is going to be the value that we're evaluating. So it's going to be something like condition expression, but we're going to need to do some work on it to turn it into something we can actually print. And I think the span of this is just going to be the span of condition expression. So this is basically saying what bit of code should I say is wrong. It should be this whole type syntax tree thing. I guess it's .node.span maybe. Doesn't have a span either. I would have thought there should be a span on. I guess is there a span on the typed syntax tree inside? No. I would have thought there'd be span on this condition expression. The typed syntax tree doesn't appear to have a span. What has a span then? Alright, digression into what has a span. Well, we know something that has a span because we use it up here. So this a token has a span. But it looks like we're not passing that on into a syntax node. And I feel like we probably should. So where do we make these syntax nodes? Excuse me. So when we are given some tokens, like this leaf token, say for example, we make ourselves a syntax tree out of that leaf token. So so we keep hold of the leaf token in that case, whereas with an operation, we've got an operator token. So maybe it's just that somewhere inside any of these syntax trees there should be some kind of token which tells us what the original expression looked like. And we're dealing with a Boolean expression, so that's an operation. Yeah, so the operation contains an operator and a left and a right. So somewhere inside there's going to be some tokens, but they could be complex expressions, so we probably don't want to get inside the earliest token inside them. I feel like we've dealt with this somehow. Maybe we wrote a method called span or block, or somewhere there was a method called span, wasn't there? I feel like there was. Yeah, so in the type check code, we wrote a method on span. This is a method on the type syntax tree. All right, so I think we were nearly there and I was just getting lost. So here, this should be, this type syntax tree should have a span method. Ah, it does, but it's private. Okay, that's why it wasn't offering it to me, so let's just make it public, because before we've only used it from inside the type checking code, but now we want to use it in the evaluation code, which is fine. Alright, so we finally got to the point where this error handling code looks fine, so if it's not a Boolean, it's fine. Now the problem we've got is that there is no such thing as a Boolean well, hold on. We've got another problem, which is cond is a value, but okay, I think this is not working because there's no Boolean variant on a value. Maybe, probably, hopefully. Let me grab my other cup of tea and bang the microphone. I like to drink 2 cups of tea. Alright, so I guess we've got to comment some of this stuff out until we have a Boolean value type. And now I guess we need to look at what we're returning from an operator, like less than or equal, something like that. So let's look at how we evaluate operation rather. So here's the operator plus, and here's the less than. Okay, less than or equals doesn't actually evaluate anything. So okay, right. We do need another step, which is we need to be able to evaluate less than or equals and return a Boolean before we can evaluate this while loop. So we're going to go back to ignoring our while test one more time. Hopefully only one more time, could be more. So ignore this. And I was just wondering why this test passes, but it's because our evaluating while code doesn't actually evaluate the operator yet. So this is still kind of passing for now. And we need a new test that says evaluating a less than or equal works for us. So let's put that a bit higher up. Let's say before mutations. I feel like this is kind of more, yeah, let's do evaluating a comparison. Comparison gives a Boolean answer. Now I feel like when we add a bool value, a load of code is going to change. So let's say 89 less than or equal to 11 is false, and 11 less than or equal to 89 is true. And I guess we should also just check two equal values, just in case. So 11 less than or equal to 11 is true. Let's just make those different, just because we like to always use different things. Or maybe we should use negative numbers, just to make it extra difficult. Okay, so it's complaining that this bool thing doesn't exist. So let's make it. Now, does bool come before? Are these going in alphabetical order? They're already not in alphabetical order. I don't know. Does bool come before I32? Is it less fundamental? It's about as fundamental, so we'll just put it there. Okay. So, now a load of stuff's going to be broken because okay, very little stuff is broken. Alright, let's see if that test fails then. Okay, so line 139, not yet implemented of evaluator. Alright, so it fails because we don't yet know how to evaluate less than or equal, so let's do it. Now we've implemented this in line here. I feel like we should be going out to a function instead of that. So let's split this out into a function. And the function's going to be called eval plus. And notice that we don't use the token that's stored inside plus because we don't actually need it for anything. Because actually that's just, at the moment, that's just storing like the string plus, which we already know what it is because there's nothing else that can be in a plus. And I have definitely thought about not having that thing inside plus, but we haven't thought that through yet. In some cases we do want the token that's inside, but not in this case. So in this case it's going to be eval less than or equals and we're going to pass in I guess we need the operator for error handling. So it's going to look similar to eval plus basically. So now we can copy this function and we can copy its error handling, which is nice. This error handling is still looking a bit verbose to me, so I'm wondering if there's a way we can make it better. Alright, so it's got a left and a right, and we're going to be able to compare i32s. Can you compare F64s? I'm noting, by the way, we haven't yet implemented adding up F64s. I also think we shouldn't implement comparing F64s because I think they can't always be compared. Oh no, they can be partially ordered but not fully ordered, maybe. We'll see. So we won't think about that yet. But we will check if their types are wrong. Then it's going to be, we're going to say, oh no, this is not the same thing. This is going to be invalid types for, I guess invalid types for operator is fair enough. And we're going to test this. Notice that to do I had in there because there was a suspicious bit of code above. So let's test the code that checks, tries to do a less than or equal, but the types are wrong. And then we'll leave in a deliberate error here so that we know that we haven't finished off this code yet. So test for things going wrong. So let's copy an error test because our error tests are really awkward because we've got all this text stuff to deal with. Well, not that one, because that one has multiple statements inside it. Let's try this one. So comparing, what's it going to be called? Comparing incompatible types. Incompatible types is an error. And the code is going to look like, I don't know, 5.5 is less than or equal to 5. We evaluate it, we get back an error. The error should say something about, what is it, invalid types for operator. And the code is going to look like 5.5 is less than or equal to 5, and it's complaining about this. I think it's just going to complain about the operator, but we'll see. That's how you spell invalid. So let's just try running this test. Try again. Like so. And it says, cannot add an integer to a float. Hang on, we're panicking somewhere. At 504. 504? Oh, somewhere just in the parsing. Okay, hold on. Our type checker is saving us. Alright, our type checking code saves us, so we never need to see this error message that we've written. So I can't test it. Which is why I guess there isn't a test for the other one, which I saw a bug in. So let's just delete my to-do, where I noticed that there's something wrong with the error handling code. Where was that? Yep. Let's just delete that and just leave it like that. And then let's write in something here that says, this should never happen because type checking. This should never happen because type checking should catch it. But I want to leave it in. Maybe the error should say something different, like this should never happen. But yeah, we'll leave it in for now because it's better to have a nice error message than none at all. So I guess I probably want to add a comment here saying comparing incompatible types is fails in the type checker. So no need for a test here. we'll get rid of that. Okay, so back to trying out this test. Okay, so here we go. It added up these two numbers. Oh, interesting, I made them add up to 100. I didn't mean to do that at all. And that's because this is because we left a deliberate bug in there. So when we compare those, they should come out as false, but they come out as 100 because we haven't implemented it correctly. So let's go back to the code that implements this. Not the while, we haven't got there yet. Not the times equals, the less than or equals, here we are. And if we've got two I32s, we compare them and we return a bool value with the answer. Okay, so we've got... Have I not actually done negative numbers yet? Okay, so our first couple of assertions passed, so we've got there. But I think I was forgetting, or getting ahead of myself and thinking we've done negative numbers when we haven't yet. Okay, my test passed. So we have comparing... We have a code that evaluates comparisons. But I think maybe we can go a bit further and actually implement our while as well. So let's unignore the test that we ignored. And it should fail again. Why have we still got... Oh, we've got warnings from this code that I haven't actually implemented yet for this, right, so that's fine. Okay, now the answer should be 1 and the answer is 0, and that's because our while doesn't yet do anything. So let's go back to where we were and try and make our while loop work. Now, I don't mean this, I do mean this. So, oh, hold on, that's because I've got the syntax wrong of how you do a let else. Here we go. Should be this. Okay, so first of all, condition expression has already been used up. I guess we can use cond here. No, because that's a value. Okay, so we have to get the span out. Oh, we did this earlier, didn't we? It's really annoying. But we have to get the span out early, just in case we need it for the error. Even though this error should never happen. No, this error could happen, right? No, again, this error should never happen because of type checking. So there must be a better way, but this is the only way that I've found so far. So we borrow condition expression temporarily to get hold of the span, which basically says where this condition is in the code. Then we evaluate the condition, and the answer should be a Boolean. If it's not a Boolean, some kind of error is happening and we need to return an error. And otherwise, we've got cond, so now we can just return cond because cond is a... So actually, we don't need to extract the bit out of cond. No, this should be cond. We don't need to extract this out and then recreate a Boolean value again. We should be able to just return it. No, wait, no, I'm talking rubbish. I was forgetting. What we're doing here is evaluating a while. So now we've got this Boolean out, this cond. We now need to say if cond. No, we're going to while in a minute, don't worry. But let's first of all if and get our first test passing. So if cond happened, then we evaluate the block. So we're going to do self.eval. Oh, now there's no eval block. But I think we need an eval block. And it's going to take in block. And it might fail. And we probably need to... Yeah, that's probably good enough. So let's make an eval block. Looks something like this. It's going to return the same kind of stuff as this. It should look like this. Why does it not look like this? Okay, so eval block takes in the block. Like that. And what it's got to do is loop through all the things in block, evaluate them, and return the last expression if there is one. Okay, so I guess we can... first of all, we need to find out whether block is a block, I guess. If not, we're in trouble. So I guess we should say, no, we need to, what do we do? What's inside block? It has a type and a node, and it's the node that we're interested in this case. So we need to say, let node, syntax node of type block equal block.node, else something's gone wrong. And for now, let's just to do this. To do return an error. For now, we're just going to panic. This shouldn't happen. Should not happen because of type checking, but we don't have type checking properly working yet. I still want to return a proper error here. So this to do I want to do soon. So now I've got hold of the statements and the final expression in this block. So now I loop through all the expressions. All the statements. For statement in statements. And we just want to evaluate it. So we could use some kind of map or something here over statements, but I don't particularly like that. And once we've done that, we then just want to evaluate the final expression, like so. No semicolon. Now, what's going wrong here? We need to dereference the statement because it's a box of a statement, and we need to dereference final expression. And we need a semicolon. And we need to fail if there's some kind of error evaluating each statement. So that looks like we've written quite a lot of the evaluate block code. Probably a bit too much because we're not actually checking. We need a test. Quick write a test. So let's just check that. Where's our while test? Here. It does evaluate the block. I want two things inside this block. Let's make this a bit easier to read by saying our code is a bit more laid out, a bit more like Rust code. And we're going to have another variable in here. And it needs to we just want to set it to, oh no, let's add 2 to ZZ each time around the loop as well. And I need to also check that the ZZ statement gets, alright, we need to do, okay. We'll have all this, but it's going to be a separate test. Or at least a separate part of this test. Maybe a separate part of this test. Because that's actually, this one is fine. This checks that like the last statement in our block gets executed, and this checks that our second from last statement gets executed, and 13 should be changed into 15, like so. Now there's more things we want to check. So far we're only evaluating the statements. We want to, if there's a final value in here, I guess that's a type error, so we can't really check that. Alright, so we've written some code in block that we're not yet testing, but we will test it when we do if expressions and stuff like that, I guess. So I think we'll tolerate that for now, but maybe I'll write a little comment there saying, where was it? Well, maybe we should not do it. Maybe we should not do it. Yeah. Let's say to do not yet tested, so not implemented. This is me being quite strict on my TDD, and instead of that we're just going to return some value, some silly value like 0, just to make sure. It should be an OK. Just to make sure that we don't write code without testing it, let's not actually even implement the bit that evaluates that final expression. Meaning that we can ignore it and deal with it later. So when later on, when I've got a block and I'm not getting the final thing evaluated and I'm really confused, you can shout at the screen and say, Andy, you deliberately didn't implement that to make sure it was tested. Because the last thing we want to do is have code that doesn't quite work because we haven't checked that it works properly. Alright, so this is almost, or very nearly almost working, so let's have a look at that test. All that went wrong here was this weird thing where we have multiple values printed every time we execute a statement. We just add a 0 here, even though it means nothing. Means that it now works. Okay, so our first test of a while loop is working. We are able to notice that x got modified when the condition was true, but x didn't get modified when the condition was false. But we want to also check that we can go around this loop multiple times. So let's just copy the simpler version of this test. I think that'll be good enough for this. And let's say a while loop whose condition is true multiple times evaluates block. This is too many words. A while loop that is true, let's have multiple times evaluates block and multiple times. Can I fit that in? No. N times. That'll do. Okay, so let's call the variable n just to satisfy my sense of neatness. So while n is less than or equal to 10, let's start n at 5. While it's less than or equal to 10, add 1. Why don't we try adding 3 and multiply these things up a bit? So let's start n at 3. No, let's start n at 6. And we want to do this thing 4 times, let's say. So 12, so 18. So let's say while it's less than or equal to 19, let's say. We add 3. So then the answer should be, now there's going to be a lot of zeros added in here, I think. But the answer should be 18, right? We're not actually checking how many times we go around the loop, so we should do that too. So let's just say let count equals 0, add 1 to count, and then print out count at the end. Now I guess we need to lay this out a bit better. Now when I did that before, oh, did I delete that code? No. Yeah, there's no need for this backslash here. We don't mind about new lines in the middle of our milk code, so we can just have new lines in there without escaping them. So this code looks something like this. We know there are going to be more zeros there, but other than that, we hope that this code might work. It's complaining because x is not a valid name, because the only names here are n and count. Because I got confused halfway through changing x to n. It's interesting that I don't get a decent error message out of this. It's not telling me where in the code it went wrong. Maybe that's just because it's not printing the error nicely. It could be that. It would be nice if that printed the error nicely, wouldn't it? Okay, and now count should... Where's it failing? Which test is failing first? So while it's multiple times while it's block n times, which assertion is failing? Is it this one or that one? We can tell that by looking at the line number. Line number is 523. So okay, so the first assertion is failing. It's saying that the answer it gets out is 9. That doesn't seem right. Oh, yeah, that makes sense. We added, we didn't implement this yet. So we added 3, it got out 9, and we stopped because the while loop doesn't actually while yet. So we need to while. This is the last bit of code for us to implement to make this while thing do. So instead of this being just an if, this is some kind of while. So let's do something like while eval while cond. Let's call this eval while cond. It does something like this, and eval while cond is going to just take in the condition expression, and we're going to need to question mark it, I guess, and it's going to do something like take in that condition expression, doesn't need the block, and do something like what we did here, get hold of all this stuff. And if it's a bool as we hope, then just return it, like so. Now it's complaining because, it should be, so it should be returning this thing if it is of type bool, basically. So for now we can just say reconstruct our bool. No, it should be a bool like this, but I don't like that. So my next job is going to be tidying this up a bit. So let's just say to do tidy up, deconstruction and reconstruction here. I feel like we've got a lot of tidying to do in the next video. Okay, so now hopefully we've extracted the code that figures out that condition. Now we can use it in a while loop. Of course, the problem is... this should actually be returning a bool, I think, which maybe makes it easier. So we don't need that to do. We return the condition like this. And it doesn't like calling... Why not? Why not? Because we've got a mutable reference, another mutable reference to self here and here. So we can't use... Is that right? Like this, because this value is being used... Oh no. It's actually saying there's no method called eval while cond. Because... Why? Because... because I've got a typo in its name. Fine. And now the problem is condition expression got moved, so we need to pass in a reference to our condition expression here. I think that will be fair enough for that. And similarly, we need to pass in a reference to this block, which means if our block should take a reference. This could mess it up. Let's see. And eval tree. Oh dear. So we've got a bit more work to do here. Maybe if we just make eval tree take in a reference. Is this going to break absolutely everything? What if everything took a reference? Except eval next, maybe. Surely this should, take a reference after dereferencing. And this should be a lot of this stuff is going to now need to look for a reference to a token. Is that how we do that? And now a leaf should take a reference to a leaf token. And that means this is going to be a reference, right? Am I doing this right? I think I'm doing it right. Yeah. So just a quick, not probably thought through switch to everything here being taken by reference. Let's find where that gets called. Then we need to take a reference here. And there's still problems because all these matches need to take things by reference. I guess assignment needs to take things by reference. Well, assignment certainly needs to take a reference here when it's calling a val tree. And here, mutation needs to do the same. So, still complaining because some of this stuff is not taking things by reference. So, where else? So, assignment, mutation. So these things, they're taking these things by value. So if I just put ref before each of them, does that make the problem go away for this section? Seems like it does. And that means that operator needs to take a reference to the operator token as well as these other things. I feel like this video should already be over, so I'm not thinking this through as well as I should. But we'll just put ampersand in a load of places and see what happens. That didn't work. Yeah, we need to pass in by reference here. And it's just cascading down through loads and loads of stuff. So less than or equals also needs to take in references to everything. Like so. And what else? So that was just one of these things. So let's do it here too. Everything by reference. And those things are not actually used, but so that doesn't work. So let's just ignore those for now. And pass these things in, dereference them, and then take a reference. Assignment should take references. Is it just that one? Maybe. And mutation takes references. And what else? Alright, so like everything needs to come in by reference. I really feel like maybe this is not what should be happening. But I kind of want to get this code working and say we're done for today. These things are much more, this is definitely right. Like, these should take in references so that we can do them later. Now, what's the problem now? Val less than or equals should be passing in references to these things. Now, getting a bit further down. And this should be taking it by reference as well. And look at that, lots of stuff going pretty well. So I need a to-do to remind me. Alright, so what we got to here was, while n was less than or equals 19, add 3. So n got to 18, then we added 3 more. So the answer should obviously be 21. And this time, when we count the number of times we increase, it'll be once when we're 6, 9, 12, 15, 18. So 4 times, right? Did I count that right? So we should be counting 4 times that we go around that while loop. No, I got it wrong. Let's try that again. So we do it when we're 6, 9, 12, 15, 18. That is 5 times. I just completely miscounted. And also this annoying thing means that we actually have another statement that we executed. So that weird 0 gets stuck in there. And our test pass. All right, so let's put in a to-do of like think about how we're passing by reference here, especially passing these boxes by reference. Because that might not be right. I mean, it's working, but it's just been stuffed in there. So let's add a little to-do. To-do, should we really pass these boxes? I think we should, but I'm not thinking about it properly now. Yeah, so we've done a rapid change right at the end here to change the pattern of how we're calling these functions within eval tree, including eval tree itself, so that we can evaluate something but still have a reference to it that we use later, still own it so we can use it later. And the reason is when we're evaluating a block, this makes sense now I'm saying it out loud. When we're evaluating a block, we need to reuse the condition every time around that block. Not when we're evaluating a block. When we're evaluating a while, we need to reuse the condition. Every time we go around the while loop, we need to re-evaluate conditions. So we need to call eval tree again. So we can't give away ownership of that condition expression the first time we call eval tree. And similarly, every time we loop around and, because the while was true, we need to re-evaluate the body of that while loop. So again, we need to, where's that? Yeah, we need to pass block by reference because we're going to reuse it next time around our own little while loop here, which implements the while loop we're implementing. Hope that made sense. Have a lovely day. See you next time.